and welcome to this new video in which I'm going to introduce to you the statistics as science. So in this video, I'm going to give you some basics that you need to know if you want to pursue a learning in statistics. And in this video, we make it into two parts. In the first part, we will have first of all presentation on one of the most important notions that we need to know in statistics, which is variable in their different types. There are two main types of variable. We present to you different variables, and the second part of this video will present to you the descriptive statistics, which is the basics of the notion that you need to master if you want to continue learning statistics. So if first time you are watching one of my videos, do not hesitate to subscribe and activate the notification bell in order not to lose the next video, and do let us thumbs up. It will be a pleasure to know that all the four we are making are helping you improve your statistical level. So let us start with variables. What are the different types of variable in statistics? So we mostly use the expression variable in statistics without really know the contents of this expression. Starting from the definition, we can say that a variable can be a characteristic that can be measured. The importance, the focus is on measure. So the variable is a characteristic that can be measured and that can assume different values. So for example, taking height or age of individual as well as its income or province of country of birth. We can see that all those characteristics can change. We have different, if we take the age, for example, we have people that have only 1 year old, other people have 20, and other have more than 100-year-old. So height, age, income, province of country of birth, grades obtained at school, and type of housing are some examples of variable in statistics. So what are the different types of variable that exist? So in statistics, we have two classifications. We have classified variable into two main categories. So we have first of all categorical variable and numeric variable. So each category is then classified into two subcategories. So for categorical variable, we have two subcategories that are nominal or ordinal variable, and for continuous variable, we have discrete and for nominal variable, we have also two subcategories that are discrete and continuous variable. So these types are briefly outlined in the section that is coming. So a categorical variable that is also called qualitative variable refer to a characteristics that can't be quantifiable. So the category, the characteristic cannot be quantifiable. So the quantifiable is the non-quantifiable is a character that what characterize really a categorical variable. So a categorical variable can be either nominal or ordinal. So that's what we can say about categorical variable that have, as we say, two main subcategories. The first subcategory of a qualitative variable is a nominal variable. So a nominal variable is one that describe a name, a label, or category without natural order. So for example, we have sex and the type of dwelling are example of nominal verbal. So in the table that follow, we have the verbal or transportation for travel to work, that is nominal. So in the table, you can see that we present, of course, method of travel to work for Canadian. So we have the mode of transportation for travel to work, and different mode of transportation, car, truck, van as driver. So we can go to work as with car, trucks, vans as driver, or you can use all those means of transportation as passenger, even though it's car, truck, or vans. So the third category that have been highlighted here is the public transits. We have also walk, so by bicycle or other method of transportation that can be, for example, on horse or any other mean of transportation that you can use. That's an example of categorical variable that is presented. So for this second sub category of the categorical variable is ordinal variable. So an ordinal variable is an variable whose values are defined by the order relation. So the main word that we should focus on is order relation between the different categories. So in the table that will follow, we will present the variable behavior, which is an ordinal because the category is excellent is better than the category very good, which is better than the category good, etc. So there is some natural ordering among variables, but it can be limited since we do not know by how much excellent behavior is better than very good behavior. So that's the table that presents some classroom student behavior ranking. And as behavior, we have excellent, 5 students that were excellent. We have 12 of them were very good. We have 10 of them that were good, and 2 of them were bad, and only 1 person in the classroom was very bad, has very, very bad behavior. So it's important to note that even the categorical variables are not quantifiable. They can appear as number in the data set. So correspondence between these numbers and the categories is established during data coding. So to be able to identify the type of variable, it is important to have access to the data. The data about the data, so they should include the code set used for each categorical variable. For instance, categories used in table 2, this table on behavior. The category could appear to be number 1 to 5, 1 for very good, 2 for bad, 3 for good, 4 for very good, and finally 5 for the modality excellent. So that is the orientation that we can give to a ordinal variable as example. So last one, the second type of variable that we just present to you is numeric variable. So a numeric variable that is also called quantitative variable is a quantifiable characteristic, contrary to categorical variable that is not quantifiable. The numeric variable is quantifiable characteristic whose value are numbers, except number which are code standing up for categories, as we just said to you previously in this given data set. So numerical variable will be a quantifiable quantity characteristic whose value are whose values are numbers. So numeric variable may be either continuous or discrete. So we have two main subcategories for a numeric variable that are continuous or discrete. So for continuous variable, we have a variable which is said to be continuous if it can assume an infinite number of real value within a given interval. So for instance, we can consider the height of a student. The height can be can take any value. So it can be negative and it can be negative. So the height of the individual can be negative, so it should be positive, and it can be higher than 3 meters because in a world population we have ever seen the person for now that is height more than 3 meters. So, but you can say that age is a variable that is set between 0 and 3, and the number of possible value is theoretically infinite. So we have infinite value that can be attributed to the height of individual student, maybe 1.6321748755 meter tall. So in practice, the method used and the accuracy of the measurement is shown with restricted precision to be to the variable. So the reported height will be rounded to the nearest centimeter. So it will be 1.63 meter. So for the age is another example of continuous variable that we can use. So the second sub category of continuous variable is discrete variables. So as opposed to a continuous variable, a discrete variable can assume only a finite number of real value within a given interval. So contrary to continuous that can take infinite number of value, the discrete can take only a finite number of real value within a given interval. An example of discrete would be the score given by the judge to the gymnast in competition. The range is 0 to 10, and the score is always given to 1 decimal. For example, a score of 8.5. You can enumerate all possible values 0.0, 0.1, 0.2, and so on, and see that number of possible value is finite. It is 101 value possible value that you can have as score in the gymnast. Another example of discrete value is the number of pupils in the household of or a household of the size 20 or less. So the number of possible value is 20, because it's not possible for a household to include the number of pupils that will be a reflection of people. So to summarize information that we just given to you, we have different two main type of variables that are categorical variable and numerical variable. So for categorical variable, we have two subcategories that are nominal variable and ordinal variable. So for numeric variable, we have also two categories that are continuous and discrete ones. So the question you might be asking yourself right now can be, what is descriptive statistic? And what I'm going to answer about this question is that descriptive statistics is a brief description of coefficient that summarize a given data set, which can be a representation of the entire or a sample of the population. Descriptive statistic can be in this way broken into measure of central tendency and measure of volatility that measure the spread. The measure of central tendency include the mean, median, and mode, while the measure of volatility include the standard deviation, variance, the minimum, the maximum variable, as well as the characteristics and the skewness of the series. So that's some introduction that we can give to you concerning what is really the descriptive statistics. So descriptive statistics can be used to summarize and describe your data graphically and as well as numerically. Can be used to identify important characteristics of a given population, and can also use descriptive statistics to share information about war data. So how to conduct a scientific project? Generally in a scientific project, you need to make a hypothesis about your study, write down your procedure by a control sample as well as variable that you are going to use in your story. You're going to assemble your material, conduct the experiment, and repeat the experience, and finally analyze your data and draw the conclusion. That's where a descriptive statistic intervene in the analysis of your, before the analysis of your results. You need to make descriptive statistics in order to see the way your data are going, so that if you are going to go much further in inferential statistics, you could have done descriptive statistics before delve into more deep analysis according to the objective of your study. So in a scientific project, generally we have principal step in that begin by the collecting of data. If you want, and if you don't have existing data, you presenting data, and after that you make descriptive statistics, a real life sample. So the basic probability theory is what we need to master if you want to do descriptive statistics. You need to handle know probability distributions, parameter estimation, confidence interval, limit, significance, and hypothesis testing is something you need to know in addition to descriptive statistics in order to go more deeper into your analysis. And the outline of this course is about graphic techniques that will be used, like bar chart, line graph, scatter plot, relative frequency histogram. We're going to see how to what is power chart and its usage. Numerical technique also part of this course. We're going to show you how to measure central tendency, volatility, relative standing, and some other graph like box plot that are again based graphically and numerically. As example, we have this bioinformatics trend since 1997. The number of universities that offer bioinformatics training program has drastically increased, as you can see in this figure on the right of the screen. The numerical data is to the right. So we have in 1999 two university giving that are offering bioinformatics, and in 2004 there were just 78 universities. You can see this upward trend in the sample that we have just present to you. So that's a good example of sample in which you can do descriptive statistic. So the first graph, as indicated, the first part of our study is graph, and we start with bar graph. That is a graph that can be used to show amounts, frequencies in categories. For example, here is on the x-axis, and the number of university offering bioinformatics program is in the y-axis. For each year, in a bar arrives to the number of schools offering the program. Instead of just viewing the number, we can instantly observe that there is an increasing trend in the number of schools that offer bioinformatics program, as you will see in the bar graph that follow. So you can see the bar graph here, and this upward trend. You can see the increasing number of universities that are offering bioinformatics programs. So increasing from just less than 10 universities. 1997 and 2004, we have more than 75 universities that are offering bioinformatics. So what another type of graph that we can present to you in this course is histograms. That is the graphical representation of a frequency table that is used to summarize categorical, nominal, and ordinal data. So histogram is used to display bar vertically and horizontally. That can be vertically or horizontally displayed. There is the area of proportion to the frequency of the observation fell into that class. So we have for this for the example of Facebook friend, useful when deadline with large data sets show outlier and gaps in data set. So we have the evolution of Facebook friends, a given sample. In the given sample, and we have many interval of number of friends. We have the mode of this sample is those who have friends between 0 and 50, and those who have friends between 2001 to 2017, 201 to 250. Have is a group of persons that have less Facebook friends in this sample. So that's a good representation of a histogram that is used in this data on Facebook friend that has been categorized in order to show the different classes, the different groups of persons according to their number of friends in this social network, Facebook. So another type of graph is the line graph. So the description is the line graph of the line graph. Is a good way, you can say, to display the change in your data over time. So you can display the changes in the data over the time using line graph. So you need to have a time interval and categorical or category on one axis, and the data to be plotted on the other. In our example, here is on the x-axis, and the number of university offering bioinformatics program. We will take this example once more. Is on the y-axis. So for each here, a point is plotted at the corresponding height.
then the point are connected with line. Again, so we can instantly observe that there is an increasing trend in the number of schools that offer bioinformatics, as we can see in the line graph, which is just the line that joins different points in the time. So it's the same evolution that we had in our bar graph that just show the upward trend that characterize the evolution of the university offering bioinformatic courses. So, for example, this example lists the test score of 25 biology students. Out of 150 points, the student score were recorded. We will look at the data in the scatter plot, relative frequency histogram, pie chart. The numerical data is shown. So in this example, we'll present this example with these 25 students. So classroom data. So we have test score of 25 biology students that were recorded, and out of 150 point, the students score were the following. We have 88, 84, 125, 88, 139, 110, 90, 93, and so on. So the scatter plots of the student will represent, and it is the simply a plot of all the test score for each student number 1 to 25. Place a point above the student number at his or her score or her test score. This plot show that the score are distributed all over, and that there isn't a lump of bad or good score, but other than that, this plot is uniformity. So you can see in this plot that the explanation that we have just shown to you previously in the description of the plot. So you just represent every student and his score in this scatter plot. So another graph is the pie chart. From the table we created for our histogram, you can also make a pie chart or a pie graph of the sample data. A pie chart is a circular graph that shows how a total quantity can be distributed among categories. In our sample, the categories are the pair grade. So we have A, B, C, and F as categories. I added a new column to our table that is percent to show the percent of the circle shared for each class, the area of each piece of pi correspond to the percent of test score in each class or category, in this case for each letter grade, as you can see. Representation of the pie chart, which is here, we have category C that have the highest percentage. Category C is of 36%, followed by category D, which is 20% in green color. Category C is yellow color. So we have this representation of the classroom data that are just highlighted on the top of the graphic and the table. So we have the different percentage of each class according to the relative frequencies. As you can just on this pie chart is with different colors. So pie chart is a suitable, is very suitable to represent category called data used to show percentage area are proportional to value of category. So we can also represent Facebook friend in the example we did previously, and we can represent people with category with 0 to 50 friend, which is in, so we can see that just is the highest percentage, 30%. So we can just move to the measure of central tendency, that is a summary statistics or measure that describe the center of the distribution. We have arithmetic mean, we have median, we have mode that can be used as a measure of central tendency, generally in statistics. That are the three main indicators that are used in the description of central tendency. Arithmetic mean is simply the mean that without imprecision is equal to the sum of the measurement divided by the number of the individual in the sample. So we have arithmetic mean that can be computed, as you can see, sum of organization divided by the total population. That is the what we call the arithmetic mean. That's the mathematical formula that is used in order to compute the mean of a given sample. And so we can also present to you the median, which is the value of the measurement that fall into middle position when the measurement are ordered from smaller to largest. So we compute the median, we need to order our series from the smallest to the largest in order to find the middle, which is the measurement that fall into the middle. So the median is a method for calculating. Here is a method for calculating the median when order of n measurement from smallest to largest. Then, if we have odd number of observation, the median n is the value of the middle measurement, or the one rank n plus 1 divided by 2. And if we have even number, then the median n is the value half between the two middle measurement. It is the average of two middle values. So in the case of we have even number, we just have two median, and we just need to have to find the average between the two. So mode is another measure of central tendency, which is the category or data that occur most often. So when on the histogram, the mode can be noticed to be the class which has the highest frequency. For example, we can use the mode and mean, mode, median for the following sample that we have 2, 3, 5, 5, 7, 7, 7, 8, and 10. And what will follow will be procedure in order to see how to calculate these three indicators. We have data set 2, 3, 5, 5, 7, 7, 7, 8, 10, n equal 9 observation, mean equal the sum of all these figures divided by 9, which is the number of observation, which is equal to 6. Median is 7, because when 7 there are 1, 2, 3, 4 observation before and after 7 when we order our sample. Mode is also 7 because 7 is the most frequent variable that we have in our sample. So that's what we can do in order to compute all these three indicators, whatever is the mean, the mode, or the median. That's used utilizing all the instruction that we just showed you previously in this series. So another measure that can be used in descriptive statistics is the measure of volatility. So after the measure of central tendency, we can present to you a summary statistic or measure that describe how data vary or how it disperse. So we can use the range, the variance, or the standard deviation as a principal indicator that can be used in order to measure with efficiency volatility. So we have the variance. The variance is of a sample is just a sum of square divided of square derivation. So the measurement of the difference from mean. So we measure the difference from mean of each observation, and we compute the sum of square of this measurement divided by the number of observation minus 1. So that's just what we call variance that must use for the evaluation of volatility. So the variance is just calculated as we can see on the screen, sum of difference to mean square divided by a number of sample minus 1. So the standard deviation of the sample is just the positive square root of variance. So we just have the positive square root of the variance. That is the measure of variation of the score above the mean, average deviation from the mean. So it's just the average deviation from the mean, because when we square our difference, is not measure a distance between observation to mean, and when we calculate the square root, it's just something like a measure that measure the distance from the sample to the mean of the sample, the mean that we just show in previously in this series. So the example that can be utilized in order to calculate all this central tendency is just the same example that we just showed you, figure 2, 3, 5, 5, 7, 7, 8, and 10 that we will use in this example in order to calculate whatever different indicator that we present to you. So the variance is just the sum of difference between number to the mean. The mean of our sample was 6, so we compute all difference to 6 square and divided by 9 minus 1, because our sample was that. The range is maximum minus the minimum of our sample, which is 8. 8 is the range of our series. And finally, the standard deviation is just the square root of our variance. The square root of our variance is equal to 2.5. That means that 2.5 is the mean distance from difference observation to the mean. The mean that's a measure of dispersion that can measure the distance from the mean observation to the sample. So the relative standing can be also introduced here. So often it is important to know that how one data point relative to other or a relative standing. So sample Z score, a measure of relative standing. So we have sample Z score that measure the distance between the observation and the center. So we have the calculation here, which is just observation minus Z score of an observation is that the observation minus the mean divided by the standard error. That's what we call the Z score of our variable that is calculated here, that can just measure the distance from the data to the standard deviation. So relative standing percentile can be also produced, and let's one x1 to xn be a set of n measurement arranged in order of magnitude. The fifth percentile is the value of x that exceeds p% of the measurement, and less than the remaining 100 minus p%. So that's what we call a percentile. So a relative percentile is a percentile like quartile, lower quantile, first quantile, for example, is 25th percentile. Second quartile, also called median, is 15th percentile. Upper quantile or third quantile is equal to the 17th percentile in the sample. That's the different representation of relative standing in descriptive statistics. So we also have a box plot, as we said earlier, which is the representation of both graphical and numerical representation of explanatory data analysis. So we have explanatory data analysis, which is the process of using statistical tools such as graph, measure of central tendency and variation to investigate the data set in order to understand the important characteristics good for saying outlying observation. Outlier can be extreme value located very far from most of the other values. They can have a drastic effect on the mean standard deviation and the scale of the histogram. So the box plot can reveal those outlier, the center of the data, on the graph, the horizontal line, the spread of the data. You can also have distribution of data present of outlier, as I said. Excellent for comparing two or more data sets. As we can see on our sample, you have A, B, C, and every of ABC have the different percentile. To construct the box plot, we need 5 summary statistics. We need the minimum, we need the first quartile, Q1, we need the median, which is Q2, is the third quartile, which is Q3, and finally we need the maximum. And we'll use all these summary statistic in order to represent our box plots with be interesting in order to detect outlier. As you can see, for example, in B, we have some points that are can be considered as outlier. How to construct a box plot. So first is to calculate the first quartile Q1, median M, and third quartile Q3. Calculate the interquartile range IQR by subtracting the first quartile from the third quartile. So the next step is to construct the box above the number of line bounded on the left by the first quartile Q1 and the right by the third quartile Q3. The next step then is to indicate where the median lies, and finally any data observation which lie more than 1.5 of the interquartile lower than the first quartile, or 0 or 1.5 interquartile range higher than the third quartile is considered as an outlier. Indicate that where the smallest value that is not an outlier is by connecting in the box plot with the horizontal line. Also mark the position of that value more clearly using the small vertical line. Likewise, connects the largest value that is not an outlier to the box with the horizontal line, and mark it with another small vertical line. Indicate outlier by dots. So the dots in the box plot will be considered to be outlier, as you can see in the graph here, representing median by vertical line. We have first quartile, third quartile, and so on. So that's it for this video.